7.7 Communication Matrices. Our learning intention: how to construct a communication matrix from a communication diagram. And our success criteria: I can set up a communication matrix to determine the number of connections between objects. Communication matrix. Matrices are useful when investigating communications involving computer systems, friendship groups, social media, and the military and travel. A communication matrix is a square matrix. So remembering, a square matrix is something that is 2 by 2, 3 by 3, 4 by 4. It's where the rows and the columns have the same number. So a communication matrix is a square matrix where communication is indicated by a 1 and a non-communication is indicated by a 0. So if these two letters meet with an arrow, you put a 1. If they don't meet, you put a 0. The leading diagonal, so I'm going to put a red line there. The leading diagonal, which is this guy down here. So you always start at the top left. And again, it has to be a square matrix. You take that down to the bottom right. The leading diagonal of a communication matrix always consists of zeros, since self-communication isn't considered communication in this context. So we go from one point to another point. So we can't get from A to A, so we put a 0. Later on in 7.7, you'll learn about self-communication links, but at the moment we're assuming that we can't get from A to A. Communication diagrams and matrices. This communication diagram, so this is the 4 dots with the letters and lines with arrows. The communication diagram shows how 4 computers, A, B, C and D, communicate with each other. So as you can see, we could get from A to D because there's an arrow pointing towards D, but we can't get from D to A because there's no arrow pointing backwards. Communication is indicated in a diagram by a line with an arrow at one or both ends. So this first one here is one-way communication. So we can get, for example, from A to point B. We can't actually in the diagram, but this is an example. The second one is two-way. As you can see, we have 2 arrow points. So we can get from A to B, and then we can get to A from B. So we can go both ways from these points. So we've got our point A and our point B. We can go from A to B, then we can go from B back to A. Whereas with the first one, we've got a point A, we can get to B, and then we're stuck there, unless there's another path onto the next point. Communication diagrams and matrices. The communication between computer A and computer C is two-way. So we're looking at this guy here. It's two-way. A can communicate with C and C can communicate with A. However, the communication between A and D, so I'm going to change that to an orange over here, is one way. A can communicate with D, but D can't communicate with A. So as you can see at the top end here, there's no arrow back again from D to A. The communication matrix M, which represents this communication diagram, is M equals, and then we've got the matrix here. I'm not going to read all the elements out. Where an element is 0 if there's no communication and 1 if there is. So we're just going to run through this diagram quickly. Just a couple of points. Now, I can get from A. Can I get to B? No. So if I go A here to B, I would put a 0. I can't get to B. I can also not get from A to A. So at the moment, I've got 2 zeros. Then looking again, can I get from A down to C? There, yes, I can. I put a 1. And again, A through to D. At the bottom there, I've got an arrow, so yes, I can. Then I move on to point B. Can I get from B to A? No, we put a 0. B to C, yes, we put a 1. Oops, I don't know what that was. B to D, no, we can't get there either. So at the moment, I've only got a 1 in that second column, and so on and so forth. So example 18. Example 18 in your textbook just has letters. I thought I'd make it a little bit more fun. Put some celebs on here. So we have, oh my gosh, I don't even remember all their character names. But we've got all Avenger characters or Guardians characters. And now if we wanted to get from point A to point B, we actually need to label them. So we've got Chris Hemsworth, we're going to call him A. Robert Downey Jr., we're going to call him B. Chadwick Boseman, we'll call him C. Scarlett Johansson, we'll call her D. And Zoe Saldana, we'll call her E. So find the communication matrix M that matches the communication diagram. So this is our diagram. Let each celebrity be represented by a letter. We've done that. We've labelled them A through to E. And indicate communication with a 1 and non-communication with a 0. So we're going to call our matrix M. Now I know that it's going to be a 5 by 5 matrix. A, B, C, D, and E. A, B, C, D, and E. Now we're going to go from the top. Sorry, I'm squeezing that in. Oh my gosh, I can't even spell from. Okay, it's with an M, not with a W. And 2. So we have a look. We can't get from A to A, so we put a 0. Can we get from A to B? Yes, so I put a 1. Can I get from A to C? Yes. A to D? Yes, and A to E? No. So far I've got 0, 1, 1, 1, 0. Then we move on to B. So we're going from. Can we get from B to A? Yes. Can I get from B to C? Yes. Sorry, B to B? No. Oops, no. B to C? Yes. B to D? No. And B to E? Yes. Remembering that all these, all the self-communications down in that diagonal will end up being 0. C. Can I get from C to A? No, because even though there's a line here, there's only an arrow on one end, not on the other. So it's only going from A to C, not from C to A. Can I get from C to B? Yes. Can I get from C to D? Again, we have an arrow to C, but we don't have one back again to D. So that's a 0, and I forgot my C to C. And C to E, I can't get from C to E at all. On to D. Can I get from D to A? No. So I put a 0. D to B? No. D to C? Yes. D to D is still a no. D to E is a no. And then our final column, we've got E. Now, there's only one communication for E, and that's E to B. So I find B, and I put zeros in the rest of them. And looking at that leading diagonal, I've got all zeros down there. Again, no self-communication matrices, no self-communication links in this example. On to example 19. So what we've done is we've taken a diagram and created a matrix. Now what we're going to do is take a matrix and create a diagram. The following communication matrix M shows direct flights for an airline that flies between 4 cities: Arcton, Brenton, Corkton, and Dunton. I didn't name them, the textbook did. Indicated by their first letters. Part A reads, complete the communication diagram by drawing arrows between the letters to indicate the direct flight. So the little note I've put there is draw single arrows to indicate one-way communication and double-ended for the two-way communication. So what I'm going to do is I'm going to draw a line each time or an arrow, and I'm going to just mark it off on my matrix just to make sure I've got everything. So starting, A and A we can't do. I can go from A to B, and I put an arrow at the end of it. Third one, A to C, and nothing from A to D. Just going to change colours. No, I won't. I'll stick with red, otherwise it might start confusing me. B to A we can't do. B to B we can't do. B to C we can't do. B to D. So I've got to do 1 down to D. On to C. C to A. Now I've already got a line, so I just put a second arrow. C to B, so we go from there up to here. C to C we can't do. C to D we can't do. And now my fourth column. D to A we can't do. D to B, again, we've already got an arrow and a line, so I just put a second arrow at the top end of that. Then D to C, so we're going from D to C, and D to D we can't do. So this is our communication diagram from the matrix that we've been provided. Part B, evaluate the matrix product N equals Km, where K equals 1, 1, 1, 1. Now, if we remember from, I don't know, 1 or 2 parts ago, this is a row summing matrix. So this means that because it's a row summing matrix, I have to add the columns. So let's multiply the matrices. We've got N is equal to, now remember, having a look at this, we've got K times M, so we have to put K first. And my matrix was 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, 1, and 0, 1, 0, 0. Let's close that off. And that equals 2, 1, 2, 2. Now remembering my matrix was a 1 by 4 times a 4 by 4. Those two middle numbers are the same, so I can multiply, and I end up with a 1 by 4 row matrix again, which I've got here, which is good, which looks good. And because I'm multiplying by a row summing matrix, I add the columns. So I add everything down there, everything down there, everything down there, and everything down there. And that gives me 2, 1, 2, 2, which is my product N. Part C, what effect has pre-multiplying K had on M? And what information does matrix N contain? Now, pre-multiplying K has summed all the elements in each column. So K being a row summing matrix, and putting it at the beginning means we have to add the columns. So if you've got pre-multiplying, you add columns. If you're post-multiplying, you'd be adding the rows. And the information N contain, matrix N shows the total number of direct flights, direct flights from each of the 4 cities to the other 3. So if we had, that's A, B, C, and D. So that's from A to 2 other cities, from B to 1 other city, from C to 2 other cities, and from D to 2 other cities. Part D, which of the cities has the fewest direct flights to the other cities? So what you do is you just have a look at what's the lowest number in that matrix. So matrix N shows that there is only 1 direct flight from Brenton. Has 1 direct flight to any of the other cities. Without looking at the diagram, I can't actually tell you which city it is. Oh yes, I can. There's the matrix. It goes from B to D. So from Brenton to Duncton. I can't remember what it's called. And there's only 1 direct flight. So Brenton doesn't travel to A or C, only directly to D. So I told you that we couldn't go from A to A. So now I'm going to confuse you and say, you know what, we can go from A to A. But we're going to start with our multi-step communication. So the first diagram I've got is a communication diagram, and that just shows you exactly what we've gone through, how you can get from A to B, you can get from A to C, you can get from A to D in one step. Now we're looking at two-step communication, or even three-step. So even though in this diagram I can't get the second diagram here, I can't get directly from A to B, I can get to A to B if I took the path of going from A to D, then D to B. Same goes for three-step communication. Can I get from A to C in 3 steps, or from B to D? Let's have a look. I can get from B to C, C to A, and then A to D. I can't get directly from B to D, but I can get from B to D in 3 steps. Two-step communication is when it takes 2 steps to get from one point to another. In the middle diagram, you can't get directly from A to B in 1 step, but you can get from A to D, then D to B in 2 steps. For a communication matrix M, M squared gives the number of 2-step communications, M cubed gives the number of 3-step communications, and so on. And how you'd find this is just put in matrix, square it, and then press equals, and that will give you your M squared matrix. And that'll then tell you how many 2-step communications there are. M plus M squared gives the number of 1 or 2-step communications. M plus M squared plus M cubed gives the number of 1, 2 or 3-step communications. We don't do too much in year 11, but you do focus on a little bit more of this when you get to year 12. Self-communication links. Can I get from A back to itself? A. Yes. From A to D, then D to A. So I'm going to, have I got this picture here? No, different picture. Okay. Yes, from A to D, then D to A. This is called a self-communication link. So I go from A to A, but I have to go via another city, so to speak, or another point. The leading diagonal in M squared, which is this guy down here, because this is our M squared, shows the following self-communication links. 1 2-step communication from A to A. So based on this, I can get from A to A in 1 step. It initially started with this M matrix. So I can get from A to A in 1 step, in 2 steps, but only 1 sort of path. I can get from B to B in 2 steps. Again, only 1 path. And D to D. I've got 2 different ways that I can get from D to D. Not going to go into too much detail about it, but I can, if I follow my path, I can get from D to A. Nope, that won't work. D to C. C to A. No, that won't work. D to C, C to D, and possibly I can't figure the other one out. That's all right, not the end of the world. But there are 2 2-step communications from D to D. So example 20. For the communication diagram representing 4 computers and the matching matrix, find the 2-step communication matrix. Now I could have shown you how to do this by hand, but that would take another 10 minutes or so of matrix multiplication, and I reckon there's a fair chance you'd be sick of my voice by now. So what I've done is I've put M squared into the CAS. So I've typed my 4x4 matrix, and then I've put to the power of 2, and I've come up with 1101, 2101, 1021, and 0010. I'm going to highlight that leading diagonal there. So at the moment I can get from A to A once, using 2 steps. B to B once using 2 steps and C to C twice. Now I've copied this same matrix up in the top corner and I've got the communication diagram, which means that we can use both. Part B, the number of 2-step communications from A to A, listing all the paths. So what you need to do first of all is have a look at the communication matrix and go, how can I get from A to A? I've got one option, or 1 2-step self-communication. So 1 2-step self-communication. From A to A. All right, now that pathway, I can get from A to B. Nope, can I get from A to B? I can get from A to D. Can I get back again? No, I can get from A to C, then I can get back to C, back to A. All right, so I'm going to put a little highlighter there and go, all right, I can get from A to C, and then I can get back again. So you can see that guy there. So the path that I'll have, is from A to C to A. So that indicates, it doesn't indicate that we go back again, it just indicates that we go from A to C, then A, using that forward arrow. And part C, the number of 2-step communications from A to B, listing all the paths. So, A to B, that's my highlighter. Oh, let's change colours, go back to green. So from A to B, I've got 2 paths using 2 steps. So not going directly from A to B, which we can't do considering there's no arrow from A to B, but finding a second path to get from A to B. I'm going to highlight those now. So I can get from A to D to B, and I can get from A to C to B. And then we drop both of those down. So we've got 2 steps. And from A to B, just so I've got everything listed, and I can go from A to C to B, or I can go from A to D to B. Now this concludes 7.7 and all of Chapter 7. Feel free to comment on anything if you've got any further questions. Thanks.